Alright guys, here we are today. Equivalent fractions is going to be this lesson. And I'm going to start off with some basic equivalent fractions that we're going to go over that you guys are probably pretty good at. And then at the end is really what the main focus of the equivalent fractions I want to talk about. First thing I want to talk about what equivalent fractions are. They are two fractions that represent the same number or value. So it's just different ways of writing the same thing. The first thing we're going to do is just practice writing equivalent fractions. So in our first example, we're just going to write two equivalent fractions. Okay, so in order to write equivalent fractions, you can do two things. You can either divide the numerator and denominator by the same number, or you can multiply the numerator and denominator by the same number. Now you can always multiply, and that works 100% of the time. You can choose a number to multiply by, a whole number, and then you will always get an answer. When you divide, it only works if there is a number that goes in the numerator and denominator. Of course, the example I gave you has one of each, or has the ability to divide. So first we can look at that division. So if I want to write one equivalent fraction, I can look and think about, alright, I can divide the numerator, and I can divide the denominator both by 4. When I do that, I get 2/3. So that's one equivalent fraction. Another equivalent fraction, I can have 8/12. I'm just going to rewrite 8/12. Got nothing else to divide by, but I can multiply. So I can choose any number I want to multiply by. I can choose 2, 3, 4, 5, 6, 7, 8, 9, 10. 177 if I wanted to. I'm just going to choose 2 because it's going to be nice and easy. So I'm going to multiply the numerator and the denominator by the same number. 18 times 2 is 16. 12 times 2 is 24. So here's an example of two equivalent fractions. 2/3 and 16/24. Now when we do equivalent fractions, there's an infinite amount of answers you could have just because of the multiplying, the fact that you can multiply by any whole number. So you could have different answers than your neighbor. You could have two multiplying ones. Your neighbor could multiply one and divide one. Sometimes you could have two division ones. Depends on the numbers. So there could be lots of answers when we go over this, but that's okay. You just need to have two that are equivalent. They represent the same thing. So 2/3 represents the same thing as 8/12. So if I'm thinking of pie, if I have 3 pieces and I ate 2 of them, that's the same as if I were to cut that same pie into 12 pieces and eat 8 of them. Okay? Or cut them into 24 pieces and eat 16 of them. Those all represent the same amount of value. Okay? All right, I'm going to move on to my next slide. Next we're going to go is simplifying. Simplifying is really where we want to concentrate on with our equivalent fractions. So when I say simplify or simplest form, this is what I mean. A fraction is in simplest form when the numerator and denominator are relatively prime. If you think back to our lesson yesterday, relatively prime means they have a GCF of 1. So a fraction is simplified when there's nothing that goes into the numerator and denominator. You cannot divide the numerator and denominator by anything but 1. 1 goes into everything, so you can always divide by 1. But if that's the only number you can divide by, that is when a fraction is in the simplest form. So when I look at 8/36, I got to think, what number goes into 8/36? Well, I have 2. Okay, I could divide them both by 2. 8 divided by 2 is 4. 36 divided by 2 is 18. I check again. Well, looks like 2 goes into them again. So I'm going to divide by 2 again. When I divide by 2 again, I get 2/9. Now some of you might have been looking at this 8/36 and said, Mr. Gasson, 4 goes into both of them. Well, yeah, you could have done it by 4 the first time, and you would have gotten 2/9. So it doesn't matter which path you take. Okay, I don't know what I have to do there. Doesn't matter what path you take, just as long as you go until nothing goes in the numerator and denominator but 1. In example B here, I look, what goes in there? 2 doesn't go in them, but 3 does. So I can divide them both by 3. 27 divided by 3 is 9. 42 divided by 3 is 14. 9/14. I am done. Okay, and that's how you simplify a fraction. It's probably work you guys have done before. Okay, I'm going to go to my next slide. In my next slide, this is what we're introducing that you probably haven't worked with yet, and that is simplifying a variable expression. And to work with simplifying a variable expression, guys, I want you to use and practice by writing them out as the factorization. So this is where our charts will come in handy again. So I'm going to write the prime factorization of each number, including putting the variables in there. So I'm going to rewrite this as 2 times 5 times x times y. That's my numerator. My denominator is 3 times 5 times y times y. So I want you to practice writing them out. So we're not going to have too many problems in tested quizzes from before. I just want to review that. This is how you need to write it out. I want you to practice by writing it out in this factorization here, prime factorization. Okay. Now I'm going to cross off what I have in the top and bottom because I'm dividing those. 2 divided, I have nothing to divide the 2 by. I have the 5s though. I have a 5 up here, can divide it with the 5 down there. So I'm going to cross them off because 5 divided by 5 is 1. I have an x, I have no x in the bottom to divide it by. I do have a y here and a y there, so I can cross those off because they become 1s. I have nothing that matches with the numerator and denominator left, so now I can multiply to find my final answer. 2 times x is 2x. 3 times y is 3y. So there is my final answer. 2x over 3y. Okay, with example B here, I'm going to write it out as my prime factorization here. So 3 times 7 times, I have 3 a's, a to the 3rd power. So I'm going to write that out, over 11 is prime, so that's just 11 times a times a times a times a. Okay, look at my numbers. I have nothing to cross cancel out. Okay, 3 does not divide with anything, 7 doesn't divide with anything, the 11 doesn't divide with anything. But the a's do. This a crosses off with that a crosses off with that a, and that a crosses off with that a. Now I write my final answer of what I have left. 3 times 7 is 21. 11 times a is 11a, so I get 21 over 11a. That is my final answer. Okay, I got a couple more examples on the next page, so I'm going to go over. Okay, in these 2 examples, again, I'm going to write it out. So that's 6b, so that's 2 times 3 times b. I'm practicing my prime factorization. Use your sheets of paper you have with all the answers on them. Okay, for 24, that's going to be 2 times 2 times 2 times 3 times b times b. Now I'm going to cross off what I have. This 2 is going to cross off with that 2. That 3 is going to cross off with that 3. And that b is going to cross off with that b. Now I'm going to look at my answer. Wait a second, I have nothing left on top. So do I put a 0? No, this is division. 2 divided by 2 is 1. 3 divided by 3 is 1. b divided by b is 1. So really on top I have 1 times 1 times 1. When you cross everything else, there are 1s there, and you are multiplying them. So on top I have a 1, because 1 times 1 times 1 is 1. On the bottom, I got the 1s, but I don't need to really worry about them. So in reality, this 1 here should be with that 1 right there. Okay, then I multiply what I have on the bottom. 2 times 2 is 4, times b is 4b. So I get 1 over 4b. And in my last example, I got 16, so that's 2 times 2 times 2 times 2 times b times c times c times c. All over 24 is 2 times 2, same as I just have right there. Again, use your sheets to help you. Times b times c. Okay, this is considered the work, guys. I need to see this on your tests and quizzes, just like this. Okay, now I'm going to divide. 2 divided by 2, 2 divided by 2, 2 divided by 2. I'm left with the 2 over 3. b divided by b, c divided by c. Okay, what do I have left on top? I have 2c squared on top. 2c, I have 2 c's left, so that's squared. And on the bottom, I got 3b left. 3b, and that's my final answer. 2c squared divided by 3b. Okay, and that concludes our lesson for today. Have a wonderful night, and we will see you tomorrow.